we will add 2 to 3 drops of barium chloride, and if we get a white PPT, then barium sulfate is formed from barium sulfate. And if we add concentrated HCl and if the solution still remains insoluble, then sulfate ion is confirmed. And if the PPT becomes soluble in concentrated HCl, then it means that sulfate ion is absent. Then we add we take again the original solution of the salt. We add concentrated HNO3, and then we heat it and add 1 ml of ammonium molybdate solution. We get a canary yellow PPT which confirms phosphate ions. For cationic analysis, for cationic analysis, we will physically check the salt. If after anionic analysis, if we confirm that sulfate or phosphate is there, then most probably a group 1 cation, that is lead, and group 5 cation, barium, strontium, calcium, this anions are most likely to be absent. And then if the salt is white color, then group D transition elements will not be present. For example, if the cation in the salt is copper, it will be blue color. If it is cobalt, then it will be brown or maroon color. If it is nickel, then it will be bright green. If it is iron, then pale green. And if it is Mn2+, it will be baby pink in color. For testing of group 0 cation, in which ammonium cation is present, we will in the salt we will add a few drops of sodium hydroxide in a watch glass, and we will then smell it. If it smells like ammonia, which the smell of ammonia is like urine, then ammonium ion is confirmed. Then if we don't get any smell, then we will move for the test of group 1 reagent, and the reagent for group 1 is dilute HCl. After reacting it with dilute HCl, if we get a white PPT, then lead ion is it will most likely be lead cation. And if we don't get any PPT, then we will move for the test of group 2, and for group 2 the group reagent is H2S and dilute HCl. In that original solution only we will add H2S, which is added to the kit's apparatus. And after adding it, if we get a yellow PPT, then it is arsenic cation, and if we get a black PPT, then it is copper. Then if we don't get any PPT, then we will move for the test of group 3 reagent. And for group 3 reagent, the test is we add NH ammonium chloride, and then we add ammonium hydroxide. But before that, if you see that the salt is pale green in color, then we add 1 to 2 drops of concentrated HNO3, which is an oxidizing agent, and it can change the Fe2+ ion to Fe3+. So after adding this, and we add ammonium hydroxide, this is done because of the common ion effect, so that this doesn't dissociate more, because if it dissociates more, then PPT of other groups may also be formed. Okay, so after that a PPT forms, and 3 types of PPT can be formed. If it is jelly-like and white in color, then it will be ammonium hydroxide, and if it is reddish brown PPT, then it is ferric hydroxide, and if it is a green PPT, then it is chromium hydroxide. But if we don't get any PPT in this group 3 in this reactions, we will divide this original solution which had this reagents also into two parts. And in first we will pass H2S again, and then in the first test of group 5 we will pass ammonium carbonate.